There was a time when everybody said, go functionless, don't use AWS Lambda, use direct integrations. But to be honest, I saw myself going back to Lambda every time. And I think there are reasons for that. Because first of all, it is easy to write. AI can write it easily, I can write it easily. Second of all, everybody who sees the code understands it. In the end, it's just code. It's just TypeScript, it's just Python, it's just .NET, whatever you use. And also, it is simply to test. So this is why I use Lambda for almost everything. If I need an API, I use Lambda as an integration. If I need to work on data after something's uploaded to S3, I use Lambda and event notifications. If I need to react to certain events, I use Lambda as a consumer. So I really go Lambda first. But there's one use case where I always go back to step functions. And this is the so-called wait for callback pattern. So that means if you have a workflow where, for example, a human is involved and you need to step the execution. This would be possible with Lambda, but this would be quite a hassle, and this is where step function really shines. So in this video, I want to show you how to build this, why we use it, and how we use it in a real-world application. In this case, it would be a content moderation platform. So let's dive into that. But first of all, who am I? My name is Sandro. I'm building AWS applications for the past 6 years. I'm building mostly full stack and serverless applications that millions of users already used. I built them in a cost-effective and performant way. And I started out, as many of you probably, with an AWS certification with a solution architect associate. After that, I thought I could build AWS applications. Turns out it's quite different and a little bit harder than the certification tells you. And I learned this the hard way. I want to teach this on this channel, how to do it and how to build real-world applications. So by the end of this video, you will understand when to use step functions, what the callback pattern is, and how to implement it in a full stack way, going from the front end through an API to the backend to an asynchronous implementation. But first of all, why do I like Lambda so much more than step functions? On the screen, you can see an example application of our CloudWatch book. And we have a pretty simple step function here. And the step function, the only thing it is doing, it is fetching some data and doing some direct integrations. But as you can see, this is Terraform. And as you can see, the code, the so-called ASL code, is not really nice to look at. And also with all of those weird replacements where we need some ARNs and some stuff like that, it's not really the easiest way to look at. And if you're a new developer, for example, you've never worked with step functions, it can be quite a hassle to work with that. Step function had some really cool additions in CDK, syntax-wise, and also how to parse data, and they have some really cool updates. But still, I wouldn't go for every workload with step functions. If you compared it to simple Lambda code is just easier to read. If you look at this Lambda function here, for example, which is from our example repository already, we have a handler, we do some stuff, we have a try catch, we understand the error handling, and we understand how everything comes together. In the step function, what you're typically doing is you call direct integrations with the SDK. So you need to fill out these parameters, for example, and then you call them like that. In a visual way, this is really nice. So let's have a look at how we build a step function in a visual way. So in a visual way, you can just get started with some template. For example, here we have a map state, we have a Lambda function within the step function, and we have a DynamoDB update item. And then you can also see you simply call here, for example, DynamoDB update item. You can give it some parameters and some stuff the SDK call actually needs. So it is not hard to create them visually. And this is also typically the first starting point. And from this visual execution, you can get the code. But if you end up in a real-world application, you typically don't go into this visual editor anymore. You need to replace some stuff. You need to replace some Lambda function names, some ARNs for different stages, for different environments you have. And this is when you end up with some ugly ASL code. So I already told you why I like Lambda. But for the pattern I show you now, I would always go with step function. So the pattern we are looking at right now is the so-called wait for callback pattern. And of course, I want to showcase you this pattern with an example application. So let's have a look at that. Here I've created a small diagram on our example application. And what we are doing is we are building a small blog publishing platform. So that means we have a user. This user can write a blog post and he can then submit the blog post. This is what we have here in blue. But in our blogging platform, what is a bit special is admins want to approve or reject a blog post. So he wants to check if this is a valid blog post or if it's spam. So here in red, we have a sticky figure with a head, and he can review the blog post. And then he simply says, okay, the blog post is fine. If yes, we publish it. If not, we reject it. And I think the special part about this architecture, about this workflow here, is that the times are different from each other. While the user is writing the blog post, this part is happening at another time compared to when the admin is reviewing the blog post. And also the special part is that we have some kind of manual intervention in here. So we have a person here which is actually checking something and then need to approve or reject something. And this is what we can build very nicely with step functions. So let's head over to the architecture, to the technical architecture. How it looks like is we have a React front end. In this front end, we simply have a small editor where we can add a blog post, and then we have an admin dashboard where we can approve or reject blog posts and see the content of the submitted blog posts. So the React frontend submits via API gateway the blog post. So the user can add new content via API gateway. I don't care about authentication in this part, so of course there's some more services involved, but to keep it simple, we simply have API gateway and we can submit the content here. API gateway then invokes a step function workflow. And this step function workflow is the important part here. In the step function part 1 is we have a Lambda function. This Lambda function saves the content and the task token to DynamoDB, because this Lambda function is actually set to the mode of wait for task token or wait for callback. That means the Lambda function waits until it is called again. And this is why we need to save the task token in DynamoDB, because we can only continue the overall step function once we call the step function again with the task token. So the whole step function workflow here is in a wait state until we call it again with the correct task token. We will see that later in the step function how it actually works. Once we call it again with this task token, we call it via an API, and then we either have an approve, so we publish the blog post, or we have an reject and we don't publish it. And the whole data is stored in DynamoDB. So we save the content in the task token, and this goes back to the React frontend because we have two routes here actually. We have a dashboard route for the admins, and we have a submit content route for the users. So this is the overall workflow which enables us to actually do this, to have the user writing the blog post and to have the admin rejecting or approving a blog post. So now we are in the web application. This is how the end result looks like. And we have some pending approvals for the admin. So we can see this is the content, don't allow that. This is spam and amazing content. So for example, here I would say reject, here I would also say reject, and here I would say approve. And if I go to submit content, I can see that this is my kind of blog post generator. So I can create something, click on submit, and then it will be in the dashboard for the admin to approve or to reject. So what's happening actually in the backend is that we have several step function executions running. And you can see that they are still running because they can run in the standard execution up to 1 year. We defined as 7 days, but they can run up to 1 year. And now if I open one, we can see its moderation and some UUID, and we can see we have the Lambda function create request. And this Lambda function waits until the API send task token success is called again. And in that case, it's not called, so nothing is happening here. And if we look into the input, we can see this is the amazing content one. Let's go to this one. This is clearly spam. We see this one. I make that a bit bigger, remove the step details. And now I reject this one. And what should happen is now we call this API. We go to approval choice. Content is rejected. It's still passed in a sense of, okay, we are done in our step function. So this shouldn't fail. Depends on your implementation. But you see we have a visual result of going through approval choice, content rejected, and we process the result. In our other execution, we need to reload this once. We can see that the content was actually approved. So the end result here is the same. This is just for demo purposes. So like I said at the beginning, the whole code, the front end, the back end, and the step function execution are all publicly available on GitHub and open source. You can simply clone it yourself and have the CDK app and deploy it in your AWS account. I just go through the most important bits now. And I just scroll down to the actual step function definition, because I think it is most interesting to start with that. So this is the step function execution. And to be honest, it looks pretty simple. We have our definition here, which comes from the create request task, which is our Lambda invoke task. And then we simply say next approval choice. And the approval choice is defined in here. So you can see that step functions in CDK are much nicer to write. So we have this chainable syntax. And our approval choice says we have SFN choice. And then when a certain string equals something, so in this case, if the approval result status is approved, then we simply pass. So step function finished with a pass state. Same thing happens also on rejected. So in a real world implementation, you would handle this a bit differently. For example, notify the user. But in that case, the step function execution are just these few lines of code. But the important part here is the create request task, because this is our Lambda task, which actually holds the whole step function onto a wait state. And we can see that we have tasks.lambda invoke. So this is kind of twofold, because first of all, we have a Lambda function, and then we have a Lambda task. And this Lambda task is the Lambda invoke task, which is in the end an SDK call to the Lambda API, which invokes this Lambda function. And we can see that we have a Lambda function in here. This is the Lambda function we define up there. So this is actually the first thing we defined. This is a Node.js function. You can check out the code here. And then if we go down back to the task, we see the most important part here, which is the integration pattern. And here we have the integration pattern wait for task token. And this is actually the part that lets the overall stop function stop until we call it again with this task token. And we actually define the task timeout here for 7 days. That means we hold the overall task for 7 days. You can also define a much longer or a much shorter timeout here, depending on your use case. So now that we understand how the wait for task token is implemented, let's look at how our submission and our approval actually works. So I think it is interesting to see our handle approve function. So this function is actually called once an admin says he wants to approve or reject a blog post. So in that case, we can look at that. We have our handle approve Lambda function. And in here, again, simple Lambda function is doing some validation. And then we query the DynamoDB. So we query DynamoDB and check, okay, is the task token, does it actually exist? And then we continue by updating the DynamoDB status, first of all, but also by sending something to the step function. So we have the step function client here, and we send the task success command with the task token and our output. In that case, a request ID and especially the new status. And this is when the step function executes again, continues, has the status in there, and we go into the choice step and check, okay, was it approved? Was it rejected? What should we do now? So this is kind of the most important part, how everything comes together in the end. So I think it is important to understand how everything works together. So again, we here on our diagram and we see we have an API gateway. We have the step function execution, which is our create request task here. This is the one that holds the step function in a wait state. Then we wait for the admin. So it is saved to DynamoDB. DynamoDB shows it in a React frontend. The admins just click on approve or reject, which again goes back, sends something to the step function via an API, via the SDK, and then the step function continues with an approve or reject status, and then the step function handles the business logic again. The whole deployment is handled via CloudFront and S3. We have a very simple deployment. We have a very simple single page application, React frontend. That means we have an S3 bucket where we store all of these files. We have a CloudFront distribution where the origin is the actual S3 bucket. And then we have a deploy command here because I want to deploy everything via CDK. So I don't want to have a separate build script, for example. And then we say, okay, where our stuff is, where our assets are, where it should be uploaded to S3, that CloudFront can reach it. That's the overall code. So check it out. I do think it is much clearer if you deploy it yourself and if you look through the code yourself. So if you would need to do this with Lambda, it would also be possible. But I really don't like the approach, because then what you would need to do is you would need to implement a polling mechanism. So it wouldn't be event-driven anymore. So you would need to implement a state in the database where you save the result of the blog post. and then also the result of the admin, and then pull in a cron job and check over and over again if this was actually approved or not, and then publish it in the same way. And with step function, you have the overall benefit of seeing visually what happened. You see the input, you see the output, and you can even give it to non-technical people and they still understand it because it's simply a diagram, right? It's the same diagram as I showed you on Excalibur. So I really like that, and for that use case, I will always use step functions no matter what. There are a few gotchas, so a few things to keep in mind. First of all, there's a token expiration, so you can define how long the token is valid. We defined it here with the task timeout as 7 days. You can define it up to 1 year. The second one is token security. So it is really important that the token cannot be publicly available, because once you have this token and once you have assigned a request to your step function and the name and the ARN, for example, then you can call the step function. So the token needs to be privately kept. Also, another gotcha is this is only working with standard step functions, and standard step functions are built by the number of state transitions you have. Keep that in mind because this can be quite expensive. For this use case, it's super cheap, but this is only possible for standard step functions. There's a second way of running a step function, which is an express step function, which cannot run for that long and which is built completely differently. So it's built by time. But there's the wait for callback pattern is not available there. So you need to use standard step function. Then there's error handling. I think in our step function, it is obvious. Content rejected works the same way as content approved. But in the real world, this is not the case. If you reject it, you want that your user gets an email, for example. You maybe not want that your step function fails, because your step function failure should actually be a technical failure. But in that case, you want to do different actions. So keep that in mind and keep the error handling on step function level. So step functions can catch errors, they can catch specific errors, they can do retries, they have timeouts and so on. So step functions are really powerful. Don't get me wrong, because I sometimes hate on them. I really like them that you can focus on your business logic, but then actually read what they can do and use their functionality. So this is it. I think the callback pattern is super helpful. I used it in almost every project I was, because you will always have some manual intervention. You will always have some asynchronous execution where you need to check something in the loop. And I love this implementation for that. We don't have an infographic on step functions. We have one in Lambda. As I said, I also love AWS Lambda. Check out our infographic on Lambda. On what you can do with Lambda, you will see everything on one sheet. You can print it out and learn it. I hope I could help you. If you have any questions, please let me know and talk to you soon. Go out and build.